Hi, welcome back to my statistics class. Today I'm going to show you some example about decided when to reject the null hypothesis and fail to reject the null hypothesis based on the stated p-value. Okay, so now let's take a look. A company concerned that to fill of its car to meet the pollution emission standard. They have 1,500 cars. They sample in 56 cars and found that 14.3 meet the emission. They want to test if it is less than 80% of their fleet meets the emission standard. They run a hypothesis test that the p-value is 0.009. So we don't need to worry about the previous step. This is just only focus on the p-value and write the conclusion. Okay, so we have our p-value equals to 0.009. So how do we draw the conclusion? It's related to the significant level, which is alpha. If it didn't say anything, the default alpha should be 0.05, which is 5%. Oh, I shouldn't say p. I should say p-value. So when you compare this, I think it would be easier if you convert this to a percentage. So now let's convert it 0.009 to percentage. We have a 0.09%. So this is really obvious that, hey, our p-value is less than our alpha. So that means we need to reject our null hypothesis. So how do we state that? We need to include in three information. First, the p-value, which is small. The second is we know that, hey, since it's small, we need to reject our null hypothesis. And then we also need to state that, hey, there's an evidence for our alternative hypothesis. Okay, so we can say that, hey, we reject the null hypothesis with a p-value of 0.009. You can write a decimal form or in percentage form. And then there is evidence for our alternative hypothesis. What is the alternative hypothesis? So that is something that we're trying to prove, that less than 80% of their fleet meets emission standards. Okay, let's do another example. So it's the probability test. So we found that the p-value is 0.273. So p-value equals to 0.273. Again, I think it's easier if we convert this to a percentage, which is 23%. Alpha, if they didn't state, should be 5%, right? 0.005. So now we have our p-value is greater than alpha. So that means what? Again, you need to include in the p-value in your conclusion. And then since p-value is not sufficiently small, so we fail to reject our null hypothesis. And then there is no evidence for our alternative hypothesis. Okay. Now let's state that we fail to reject our null hypothesis with a p-value, or we can say give more details, such as with a not sufficient small p-value of 27.3%. There's no evidence that their county has a different poverty rate than the rest of the US. Okay, so C, again, they have a p-value of 0.06. Which is 6%. Our alpha is equal to 5%. So now our p-value is greater than alpha. That means our p-value is not sufficiently small enough to what? To reject the null hypothesis. That means we fail to reject the null hypothesis. We don't have enough evidence for the alternative hypothesis. So now let's state that we fail to reject our null hypothesis with a p-value of 6%. There is not enough evidence for our alternative hypothesis, which is what they're trying to prove. Null hypothesis, something that they're trying to prove that, hey, the study such drug and look for the evidence that the side effect exists. So we can say, hey, there's not enough evidence for that drug, the side effect exists. Okay, that's it.